Welcome my fellow engineers. Today we're gonna dive into some code that'll make your servo motor dance like nobody's watching. This Verilog module is gonna help you interface with your servo motor with any digital system. Now, let's get on to the good stuff. Their servo motor is like the Beyonce of robotics. It's got the moves and precision. Our Verilog module controls this diva using a counter that generates a pulse width modulation with the frequency of 50 megahertz using the clock wizard. It's like a super fast beat. I'll get your motor moving. This code takes in a system clock signal and it outputs a control signal for your servo motor and an LED right there that indicates the state of a test control algorithm. We even got a fancy module called Clock Wizard that helps us generate the clock signal with the perfect frequency. Now, this counter counts up on every positive edge of the clock signal. Well, enough boring stuff. Let's show you a demo. So, open hardware target. Auto connect. And let the party begin. Yeah, let's go. So I was saying the counter counts up on every positive edge of the clock and resets to 0 when it hits 1 million. The counter value is what we use to generate the pulse width modulation signal that controls the servo motor. This baby has a range of 180 degrees and its maximum pulse of 2 milliseconds and a minimum pulse of 1 millisecond. So we have to use a counter to generate different pulse widths to make the servo motor move the way you want it to. It's like having your own robotic dance DJ. Now you may be asking, what is this little thing? Good question. So I use one top module that controls two systems, this LED here and the servo motor. The LED is controlled by the RGB rainbow, as you can see here. So what's the secret behind this magical LED? Well, again, it's all the pulse width modulation signal. This module uses a 50 hertz clock to generate the 3 pulse width outputs that correspond to the RGB's LED green, red, blue, and green signals. But wait, there's more. The main logic of the module is divided into 3 sections: a counter, a main counter, and a set of duty cycle registers. Every 45 degrees of the main counter, the duty cycle registers are updated. So not only is the rainbow RGB creating rainbow colors, but it's also throwing a dance party inside your circuit. Can your module do that? I don't think so. And just in case you're wondering how all this magic happens, it's all thanks to Verilog and System Verilog. As you can see here. Well, thank you again. Thank you, Saba, and I'll see you on the next project. Goodbye. Oh, reset.